Hello friends, this is Priyanka. Today we are going to obtain mathematical model for a given mechanical system. Now if we observe this system, there are three masses, that is mass m1, m2 and m3. Whereas this mass m1 and m2 is having contact surface with this floor. And in between these masses and floor there is the viscous fluid present. And here in this question, viscous friction coefficient is given, that is Fv1 in between floor and this mass m1. Then viscous friction coefficient in between this mass m2 and floor is Fv2. In the same way, this mass m3 is in contact with the upper surface of mass m1 and this mass m2. So in between these two surfaces, viscous fluid is present. So viscous friction coefficient in between m1 and m3 is Fv3 and viscous friction in between this mass m3 and m2 is Fv4. Then force F of t is the applied force towards the right hand side direction, and because of that there is the displacement x1, x2 and x3 that is taking place for these masses m1, m2 and m3 respectively in the same direction of the applied force. Here spring K1 and K2 is also there. Now to obtain mathematical model, we have to first draw the free body diagram. So we will first take mass m1. Then for this mass m1, if we observe displacement x1 is there towards the right hand side direction. So we have to show the reaction forces. Now action force is F of t and the reaction forces are also present. So how to show the reaction forces? So we have to show the reaction forces in the opposite direction of the action force F of t. Now regarding this mass m1, which elements are responsible for this reaction forces? So we will first observe. So here spring with stiffness K1 is there, inertia force due to mass m1 is there, then spring with stiffness K2 is there, then here viscous friction coefficient Fv1 and viscous friction coefficient Fv3 is also there. So we have to show that. So I will show all the forces in the opposite direction of this action force F of t. So first I will take here, we will show here all the reaction forces. Now first I will take Fk1 because reaction force due to spring stiffness K1. Then here is the inertia force due to m1, that is Fm1. Again Fv1, then Fv3. Then on this side or this face of the m1 there is K2, that is spring stiffness K2 is there. So I will say Fk2. So all are these reaction forces. So according to Newton's second law of motion, we can say that summation of all the reaction forces is equal to 0. So how we can write here the equation? That is, I will write Fm1 plus Fv1 plus Fv3 plus Fk1 plus Fk2, which is equal to 0. So this is the equation. But applied force is F of t, and what is the output? Output is displacement x1 is there. So we have to define all these forces in terms of displacement. So we will first take inertia force due to mass m1. So mass m1 is having displacement x1. So how we can define? That is m d square x by dt square. But instead of m we will take m1. So I will write here m1 d square x1 by dt square plus Fv1. Now here viscous fluid is present. Viscous fluid is present in between this mass m1 and floor, and this m1 is having displacement x1. So we know that what is this viscous fluid, that is we have to take viscous friction coefficient. So this viscous friction coefficient is given Fv1. So we will use same here, that is Fv1 in the bracket dx by dt. So instead of x I will use dx1 by dt. plus FV3. So this is also the viscous friction coefficient. So for this viscous friction coefficient, again if we observe, it is present in between this M1 and M3, and M3 is also having displacement x3. So we have to take the difference. So while taking difference, this is the free body diagram of M1 which is having displacement x1. So we have to take x1 first. So how to take? So I will write here FV3 in the bracket dx1 by dt minus dx3 by dt. Then again spring K1. So spring K1 is attached to only M1 and M1 is having displacement x1. So I will write here K1 x1 plus spring K2. So K2 is attached in between M1 and M2 which is having displacement x1 and x2. So here we have to take the difference. So we have to take x1 first while taking the difference. So we will use here K2, that is stiffness is K2, and the difference for displacement is x1 minus x2. Bracket complete, which is equal to 0. So this is the differential equation for this mass M1. Now we will move for the next mass, that is the mass M2. So if we observe the mass M2, again which elements are responsible for the reaction forces? So here viscous friction coefficient FV2, viscous friction coefficient FV4, then spring K2 is there, that is getting attached to M2 and M1, and here action force is F of T. So again we will draw here free body diagram. So reaction forces due to these elements we will show in opposite direction, and inertia force is also due to M2. So first I will take here inertia force due to M2, that is I have to write here F M2, then force due to K2, that is reaction force due to K2, F K2, then the reaction force due to this viscous fluid, that is FV2, and the reaction force due to this FV4. So we have to write here the equation. So according to Newton's second law of motion, again action force is equal to sum of reaction forces. So action force is applied on this M2. So how we can write here? F of T is equal to Fm2 plus Fk2 plus Fv2 plus Fv4. Now we have to define all these reaction forces in terms of displacement. So how we can define Fm2? That is md square x by dt square, but x is nothing but x2 and m is nothing but m2. So d square x2 by dt square. Now what about the spring K2? So K2 is in between m1 and m2. So we have to take the difference in between these displacements. So we are going to take here the free body diagram for M2. So we will take displacement x2 first while taking the difference. So stiffness is K2. So I will write K2 in the bracket x2 minus x1. Then FV2. So FV2 is related to M2 only. So this is the viscous friction coefficient. So I will write FV2 then dx by dt, that is dx2 by dt, plus Fv4. Now V4 is present in between M2 and M3. So I have to take the difference of this displacement. So again I will take Fv4 and in the bracket we have to take difference, that is dx2 by dt minus dx3 by dt. And on the left hand side there is f of t. So this is the second differential equation. Now we will move for M3. So if we observe this mass M3 here, what is the connection? So for this mass M3, inertia force due to M3, then FV3 because of this viscous fluid, and here is also viscous fluid in between M3 and M2. So now I will show that. So first I will take inertia force due to mass M3, then force due to viscous fluid or viscous friction coefficient FV3, and again in reaction force due to viscous friction coefficient FV4. Now I have to write the equation. So all our reaction forces, displacement is x3. So summation of all forces is equal to 0. So what is the inertia force due to M3? That is M3 into, now displacement is x3, that is d square x3 by dt square plus FV3. So here V3 is present in between M1 and M3. So we have to take the difference of this displacement. So here free body diagram for M3 which is having displacement x3. So we have to take first x3. So how we can take? So this is viscous friction coefficient. So I will write FV3 in the bracket dx3 by dt minus dx1 by dt. In the same way, FV4 is in between M3 and M2. So we have to take the difference of this displacement. So plus FV4 in the bracket dx3 by dt minus dx2 by dt, which is equal to 0. So this is the third differential equation. So I will give here the numbers. This is the first, this is second, and this is third differential equation. So these three equations is nothing but the mathematical model for this given mechanical system.